My name is Lars Nielsen. I'm a test engineer from Keysight Technologies. I'm here to give you an introduction to OpenTAP plugin development. First, I will give you an overview via some slides. Then I will show you a hands-on demo where we develop a plugin. First, I will present the use case. Then I will go through what you need in terms of tools and software. So I'll start with giving an overview of the use case and what we want to achieve. If you watched the previous training session where I gave an introduction to OpenTAP and how to use it, you might recognize this use case. We have an ambulance and a hospital. We want to send critical information about the patient from the ambulance to the hospital. For that reason, we want to measure the network connection between the two entities. Last time I showed how this could be done using Hawkeye and controlling it via OpenTAP. But maybe we want to use a different tool, such as iPerf. iPerf measurements are started from the client via command line. This can also be done sending commands via SSH to the client. So our goal is to automate this process and to be able to easily execute measurements from multiple clients. To control iPerf using OpenTAP, we need to develop a plugin. This plugin could contain an instrument to manage the SSH connection and test steps to configure and execute measurements. This will allow for easy reusability and ensure scalability. As a reminder from the previous training session, here we see the OpenTAP architecture. We have OpenTAP in the middle as the sequencing engine and all added functionalities as plugins around it. We will be using the desktop editor and SDK plugin from the user interfaces. And we will be developing instruments and test step plugins. To show the process of creating the iPerf plugin, I will first go through some steps to show different options. First, I will create a general SSH plugin. In doing this, I will first create a step that connects to a machine and executes a command. Next, I will create a step that handles the connection and another step that executes the command. After that, I will create an instrument that manages the connection and a test step that executes the command using the instrument. Finally, I will create an iPerf plugin that inherits from the SSH plugin. In the iPerf plugin will be an instrument and a test step that configures and executes a measurement. So this is to show the progression of a plugin development. When developing plugins, there are a number of resources that will help you and make the process easy. Here are first some resources of information. The OpenTAP webpage, of course, the documentation and developers guide, and the project on GitLab where you can join the community. I highly encourage you to explore these. In a moment, I will show a practical demo where I will develop a plugin. In doing this, I will be using these things. I will develop in Visual Studio coding in C#.NET Standard. I will use some OpenTAP plugins, such as the Community Edition of the editor and Visual Studio SDK. I have already set up two machines, one running iPerf server and one iPerf client. As the SSH client, I will use the Renzi SSH net package, which is a NuGen package. Okay, with that, it's time for a demo. After the demo, there will be a Q&A session, so please stick around. Okay, so we're here in Visual Studio now. So let's start with creating a new project. Now we see that one of the templates we have is the OpenTAP plugin project, which is a .NET Standard project. This is what we will use. This is provided from the SDK plugin. So let's give it a name. Okay, and we will put it in this folder, that's fine. Okay, so this creates the project and initial test step. Now we see here in the test step that it provides us with some initial things. So we have the settings, which is where we will fill in parameters that the user will be able to modify from the editor. We have the constructor, which is where we can do things such as set default values for the parameters provided to the user. And we have the run function, which is what will be executed during the execution of the test plan. But I don't like the name of this, so let's delete this and create one from scratch. Okay, so we can right click here, select add. Now we have a bunch of different templates available, but let's search for OpenTAP. So here we see a number of OpenTAP templates available. We have a DOT, instrument, result listener, and so on. We are interested in the test step. So let's call it standalone SSH step. Okay. So this creates the same as what we saw before, but now with the naming that we actually wanted. So let's start with filling in the settings. These are what we will actually need to make a SSH connection and execute a command. So first off, we will need a host. Adding this get and set will allow the OpenTAP editor to know that, okay, so this should be modifiable by the user, and because it has the type string, it will show a text field that the user can fill in text in. Additionally, we can add some attributes to this parameter such that the editor know a bit more how to visualize it. So we do that using the display function. Here we can add a name, which will just be host. We can add several different things, such as description. Now I think host is self-explanatory, so let's leave it without the description. Now, group might be interesting. Group is how the editor will group the settings in the settings window. So we will add a group called connection, because the host is part of the connection. Okay, so that was one. Now what else do we need? We need a username. We need a SSH key. Now here we will just ask the user for the path to the key, then we will load the key in the later on. And finally, we will need a command. Now we will put this in a different group called command. Now I said that we will ask the user for the path to the key. This we can actually let the OpenTAP editor know by providing it with the attribute called file path. With this attribute, the editor knows that it should present this parameter with a button that the user can click and allow him to browse through his folders to find the key that he wants to use. Okay, so I think that's the parameters we need for now. Here we can put in some default values, so let's do that. Username. We cannot give a default path to the key, so we will just leave that out. But in the end we will add the command. So this command will just print some information about the system that we are connected to. Good. So we are ready to actually create the content of the run command. mentioned earlier that we wanted to use the Renzi SSHnet package, so let's start with adding that because I know we will need it now. We will go to Manage Nugent Packages, browse and search for Renzi. Add it to our project. Yes. Good. And tell it that we want to use this package. Alright, so to begin with we need to first load the key. So we will do a private key. I will just name SSH key. Now this we need the file name, which is our SSH key URL. So this will load in the key in this object. Next, we will be creating a SSH client. Which have a number of different constructors. We want to use this one, where we include the key file as well. So we have the host, username and key file, which in our case is the host, username, and SSH key. Good. So let's start with connecting. Next, we can run the command. Now, here to make sure that the user have not put in something fishy or Windows Linux compatibility issues, we will make sure that some issues are removed. So we start with removing this one and also this one. So this run command will return the SSH command object. This is where the output will be stored in. So let's do that. Put it in here. Now we want to check the output of the execution of this command. So we start with checking the exit code. Exit status, sorry. If it's 0, then all is okay. Else, we would have had an error. So up here, we will set the verdict of this test step we are creating. So pass. All down here, we will set it to fail. Now we could do a more smarter interpretation of this, because maybe the command failed on the host, but the SSH connection in itself was not a failure. But for now we'll just put it like this. Here we want to print out the reason. Now here we want to go through the results. We want to split it into lines and then print out each of those lines. To print out each of the lines. Good. Now, one last thing we miss is disconnecting from the host. So we have created a test step as part of the SSH plugin. We have the needed information to perform the connection. We have a command. We have set some default values, and we load the SSH key, connect, execute the command, print the command, and disconnect. Now before executing it, I want to show you this project file. You can go here, and right now it's set to execute using the developer system community edition. Now this includes some additional packages such as debugging and other stuff, but for now we just want it lightweight and quick, so we will just use the editor instead. Down below here we see the Renzi SSHnet package that we installed earlier. Good. So we are ready to run. Hit F5. And the OpenTAP editor community edition is launched. So let's look at the steps. We'll dock this window. Like that. In the steps browser, we now see we have the default steps, such as basic steps and flow control, and then we have the steps included in our plugin. You see the standalone SSH command step that we added. So let's add this. Once added, we can see the settings available. Remember, we did the two different groups. We have the command and the connection group. Now here we will put in an actual IP. And here I will load key file that I have created in advance. And the username is Ubuntu. So we'll leave that. Okay, let's try to write. So that's done. We see the verdict passed. In the log we can see that it started the execution of the plan. It executed the test step and printed out the line that it received from the executed command. And the verdict of this test step was pass, and then it prints a summary. So that's quite simple. Okay, so let's return to Visual Studio, close this down. And let's add another step. First we will create a step where we create the session, and then we will create another step that uses the session created in the first step to execute the command. So we will start by adding a new item. This should be a test step also. So we will call it SSH session step. Now in this one we wanted to do the session, so part of the things that we have done in the previous step, we will use all the connection parts. Remember to include the Renzi SSH package. We will also set two default values. And then we will copy this, but only use part of it. So, of course, we create the key, that's fine. Now we wanted to hold the session in this, so we will make a specific object for holding the client session. We wanted to make this internal. Make sure it can only be modified from inside this one. So here we make the client. Viewer client connect. Then we want to run child steps, and then we want to do a client disconnect. We can remove all this. So this means that we set up a connection, we run child steps, and then we disconnect. So let's create the step that we wanted to run as a child step. A new test step again. So call it SSH command child step. Now here we basically need the command part from the initial step we created. We want to set a default value for that. And then now we wanted to run this as a child step of the SSH session step. And we only want to allow it to be added as a child step of that, otherwise it doesn't make much sense because there will be no session to use. So we will add that as an attribute. Then we can use this allow as child in. We will get the type of SSH session step. So this will mean that we are only allowed to add this step as a child step of the SSH session step. Good. Then we can add the dependency package. And create the SSH client we want to use, which we will get from the parent step. On this, we will run the command. Now we see similarities to the first step again, so we will use this same code. So using the client to run the command, replacing new lines, unwanted breaks, get the output, check the exit status, and print the result, and update the verdict accordingly. So let's try to run this. 5. Now back in the OpenTAP editor, we see we have added additional steps. We have the command child step and the SSH session step. Now the command child step we are not allowed to add because it can only be added as a child step of this one. So let's first add this one. We see we have the connection parameters. Now we can see we can actually press this button, add as child, and we can drag it in as a child step to this one. So let's fill out the information again. We will load the same key again, same username, and just use the default command. Okay, we got passed again. So let's check the log and see what was actually printed. So we started with the SSH session step. Then we run the child step of the SSH step. We get the output from the command. The child step passed, and the session step finishes with also with verdict pass. So we can see that it's executed in this order. So that's go back to Visual Studio. Let's close this. And let's try another way. We will create a plugin handling the SSH session instead of the SSH session step. And then we will create a test step that uses this plugin and the session held by the plugin to execute a command. So let's go to add new item. Now we want to add an instrument. So let's select this one and instrument. Okay. This creates a slightly different template from the test step. It inherits from this instrument. Per default is set to the Skippy instrument. Now in our case we just want to use the default or basic instrument to inherit from, so we change it to that. Again, we have a number of we have a settings area where we can add the settings in the same way as for the test steps. We have the constructor of the instrument. Then we have two very important functions. We have the open and close. So the open function will be executed before any of the test steps in the test plan are started, and the close will be executed after all the test steps in the plan are done. Meaning that this would be a very good place to open the SSH connection to the host, and this would be a very good place to close the connection to the host. So let's do that. Let's start with adding the Renzi package. Good. Then we will use many of the same things as we did for the session step. So to quick things up, we will just copy these things. So again, we will have a local parameter holding the client that we set up. We will have the host, the username, and SSH URL. Let's change the name to this SSH instrument. So this is what will be made visible to the user when adding the instrument. Then down here we will create the key and make the connection similar to what was done here. Now additionally we can also set some default values for the parameters here. And finally down here we will close the connection. Okay. So with that ready, we can create a test step which will actually use the connection held by the instrument. So let's select test step. Then we'll call it SSH command to instrument step. Again, this step will be much similar to the SSH command child step we created earlier. So we can copy things here. Copy the default value. We need one more thing. We need to actually point it to the instrument that we want to use. So we can do a public instrument. So this will allow the user to actually select which instrument to use. So in the case we have multiple instruments set up for making connections to different hosts, then we can select the specific instrument, so connecting to the specific host that we want to execute the command to. Again, here we can add a name. And let's make a group. So now we are ready to try to use the connection that the instrument holds. But before we want to use it, we want to make it just a little bit smarter, or simpler for the user. So here we will make a function called onCommand, which will return a SSH command object. We will take a string as input. Here we will again do the right handling of the input to make sure that everything is interpreted correctly. So doing it in this way, we don't have to fiddle with the client object in the test step that is executing the command. So let's go back to this, meaning that now we have our SH instrument dot run command. Here we can just put in our command string. This will output which we again will handle in the same way as we did previously. So now we have created a plugin. We set up a connection. Once the test plan starts, it opens the instrument, and in doing that, it sets up the key and creates a client and performs the connection. Then the test step is executed, which will use the command that is given by the user, and it will use the instrument that we have selected in the editor. It will execute the command by using the run command function that we have just created in the instrument, taking the output and evaluating and printing it to the log. So let's try to hit F5. Okay, so we're back in the editor. Now we see we have the SSH command to instrument step available. So let's add that. In the settings we see we have the command that we can execute, and we have a group called instrument where we have an SSH instrument. Now there's nothing to choose here. That's because we have not created the instrument yet. So let's do that by going down to the resource bar, clicking the plus, and we see under our plugin we have an SSH instrument available. So we will add that. Now we see the connection options that we have made available. Let's fill it out. Load our key and the username we will leave. Okay. So the instrument has been created. Now we can select it here. And we see right now the instrument is disconnected, indicated by the gray dot here. Once we will hit run, we will see this turning green, indicating that the connection has been made to the instrument and that the open command in the instrument has been run. So let's try to run the plan. Okay, so let's look at the log. We see that it starts with opening the instrument, so the SSH instrument that we have created. It runs the test plan, running the test step that we have created, gets the verdict from that, prints the summary of the executed test plan, and finally, in the end, closes the connection to the instrument. So that worked out quite well. So with that, we have created our SSH plugin. We have shown how to create a standalone step with everything included. We have shown how to create a step that holds the session and another step that uses that session. We have shown how to create an instrument and a step to use that instrument. So this is a pretty general plugin that can be used in many aspects. SSH is a general tool. Now we actually wanted to create a specific plugin to use when controlling iPerf. So we can do that by leveraging what we have already done now with the SSH plugin. But first we need to create a package file that we can reference. We can do that by building the package with this command. So we go into the project folder first, and then we execute a TAP command, which is called TAP package create. We give it the directions to the output file and point it to the package XML, which is included in the project. This outputs a OpenTAP plugin package file, TAP package file, that we will then reference in the iPerf plugin that we are about to create. And based on that, it can inherit some of the features and functionalities from that. Okay, so with that done, we can close this down, close the editor, and we now want to create a new project. Again, we use the OpenTAP plugin project template. We will call it iPerf plugin and just leave it in that folder, that's fine. Again, don't want to use this default step, so we delete that. So let's start with going to the project file, where we will do some modifications. First, let's change this to the editor community edition as well. So this is just for speed when running the project. Then we will want to add a reference to the SSH plugin. We can do that here. Use this. Now without the version, call it OpenTAP plugins.sh, and this is as a OpenTAP package reference. Now we will also need to give it a path to where we can find it. So here we could actually point it to an online repository, OpenTAP package repository, and then whenever we run this package, we would download it from that repository. For now, however, I just want to use it locally. So I'll just paste the path to the file here. So this is the TAP package that we just created before. Okay, close that down. We also want to add the Renzi package. So just add it like here. So this is the same way as we added it for the SSH plugin. Good. So to begin with, we want to add an iPerf instrument. Go that by templates. We select the instrument and name it iPerf instrument. And add that. Now again, here we want to use the SSH plugin instrument. So to begin with, we need to tell it that we want to use that package. Then instead of having a SKP instrument or a standard instrument, we want to use the SSH instrument. This means that all the features and functionalities that are included in the SSH instrument will be inherited by this instrument. So if we want to add some additional settings, we can do that, but otherwise the settings added in the SSH instrument will be included here. Now we maybe want to name it iPerf instrument, and maybe in addition to the open command performed in the SSH instrument, we want to do just a version check of the iPerf tool on the host here. So we will use this run command. We will run an iPerf free command, querying the version of the iPerf tool. So this will, if it's installed and executed successfully, it will return information about which iPerf version is running on the host we are connected to. So we want to take the output of this command, split it into lines, and print out each of these lines. Now this will just check for the version of iPerf running on the host and print that out. In the close function, we will not do any changes. We will just leave it as is, so it will inherit whatever it's done in the SSH instrument. Now we can add the test step for executing an iPerf measurement. So again, we go to add, we select test step, Now here we need to put in a bunch of parameters to help the user configure the test that he wants to execute. But first we need to add the instrument. We will make a group for that. So now we are ready to start adding specific parameters to configure and run the iPerf measurement. If you go to iPerf webpage, we can go to the user docs. Here we can scroll down to see the client-specific options. We can see we need to give it a host, so the server to run the test against. We can see we can indicate which protocol to use. In our case, we will just use UDP or TCP. We can indicate the bandwidth, the target bandwidth to test with. We can indicate the time, the duration of the test. And finally, we can indicate what direction to test in, normal or reverse, so upload or download, basically. So these are the parameters that we will limit ourselves to. So some of these might be a good idea to define a common place. We will do that here in the instrument file. So here we can create a enum protocol. And we will create another enum named direction. So going back to the test step, we can start defining the parameters. First we need to define a host. We can name it iPerf server. Then it might be a good idea to create a group called iPerf test settings. So we also have the protocol. We have the direction. Now here for protocol and for direction we used the two enums that we just created. Making it enums will allow the OpenTAP editor to present the parameters as a drop-down menu, making it quite simple for the user to choose which value to use. Then we also had the bandwidth. Maybe here we want to indicate that that's in bits per second. We have the and finally we have the test duration. Well, we might want to indicate that that is in seconds. Okay, so let's go to the constructor and set some default values for the parameters. So for the server, now I know that it's running on this IP. We'll set the default protocol as TCP. We'll set the default direction as downlink. We'll set the default bandwidth as 0 and indicate that if it's 0, then it's unlimited for TCP and 1 megabit per second for UDP. So this is as defined by iPerf. Lastly, we have the test duration, which we will set to 10 seconds. So now we are ready to fill out the actual test step, so what is being executed when the test plan is being run. We will create a string builder, which we will use to create the iPerf command. So we start with building the command using the iPerf3, indicating we are running as client, and putting in the server that the user have filled in. Then we will append the test duration. We will add the protocol. Now in iPerf, the default protocol is TCP, so it's only if it's UDP we need to indicate it. Similarly for the bandwidth, if it's not 0, so not the default, then we will add for direction. So the default direction is downlink, so only in case that it's uplink, then we will add something to our string builder. So that was all the settings we have. So here we have creating the iPerf configuration. So here we can actually run the tests. And this is very similar to what we did for the SSH plugin. We have the iPerf instrument. We will use the run command. Running our iPerf configuration that we have built. This will again return the SSH command object that we will check for the output. So with that done, we are now able to create an iPerf instrument, which is inherited from the SSH instrument, where we reuse the same settings, the same open and close functions. In the open function we have added an additional printing of the iPerf version, just to check that it's installed and ready. We have created a test step which uses this iPerf instrument and configures an iPerf measurement in terms of the iPerf server, the protocol, direction, bandwidth, test duration. We have some default values for those, and we configure it and run the iPerf test, printing out the results. So let's see how that looks. Hit F5. So first we see that it's looking for the SSH package. It's installing it in the OpenTAP session that we're running it in now. And once ready, it opens the editor. So let's add the step panel again. Now we see something slightly different. We see we still have the SSH plugin from before, but this is actually installed from the package that we created earlier. Then we also have the iPerf plugin. Here we have a single step that we have created. If we add this to the test plan, you can see we can select an iPerf instrument. We have not created that yet. We can select whether we should be uplink or downlink. We can indicate which server to test against. We can select the protocol and indicate the target bandwidth. Now if we do hover, we will see it showing the description that we added for the settings. And finally we have the test duration. So let's first add the iPerf instrument. We go to the resource bar, click on instruments and the plus button. Here we see we now have two groups, the SSH plugin and the iPerf plugin. Selecting the iPerf instrument and adding it will give us this one. Now this is exactly as the same settings as what was for the SSH plugin. And this is of course due to it inheriting from the SSH plugin. So here we will give the host information. We will add the key and the username is okay. Then we go to the test step and select our newly created iPerf instrument. So let's try to run it. See that it opens the iPerf instrument, it checks the version and prints it. And runs the test and prints the results that we get in the end. So here we see that we were testing between two machines where we got around 880 megabits per second in the one direction. So this was due to us running a TCP test with no limited bandwidth. So with that, we have created an SSH plugin. We have shown different ways of interacting with an external tool, both doing it directly through the test steps and doing it using an instrument. We have also shown how we can create TAP packets, how we can inherit functionalities from that TAP package in another TAP package, and in that creating the iPerf plugin which interacts with the iPerf tool. So with that, the demo is done. Thank you. So with the demo done, we are now ready for your questions. Thank you for your attention.